Hey guys, here are the R8 notes. Okay, radicals and rational exponents. What is a radical? It is the inverse of an exponent. So the square root of 25 is 5, right? Similarly, 5 squared is 25. That is how radicals are related to exponents. Okay. To use your calculator to find these, second, and then the x squared button will give you just the radical, the square root. If you need a bigger square root, you can go to math. Here's 3. So it's a cubed root. Or this one means you can put any number you want. So 6. There. Now it's up there. 4, 0, 9, 6. That means 4 6 times gives you that number. The odd root of a negative number is negative. The odd root, what's this? The 3 is odd. The odd root of a negative number is negative. The answer will be negative because this is odd and this is negative. But the odd, 3 is odd, the odd root of a positive number is positive. If this number is even, because this is a 2, right? If this number is even and this number is negative, the number is not real. Or the example we just did, 6. The 6th root of 4096 is 4. But the 6th root of negative 4096 is also not real. You cannot take the even root of a negative number. Okay. So let's work these examples. The cube root of 64 is just asking what can we multiply 3 times to get 64? It's 4 times 4 times 4. So the cube root of 64 is 4. Now I have the cube root of negative 8. What can you multiply 3 times to get negative 8? Probably a pretty small number, right? Maybe 2 times 2 times 2 is 8, right? But it must be a negative, right? Because negative 2 times negative 2 becomes positive 4. But we multiply it by a negative 2, we get negative 8. So the cube root of negative 8 is negative 2. If you have a fraction, you can distribute the radical to both the top and the bottom of the fraction. the fourth root of 1 over 81 becomes the fourth root of 1 over the fourth root of 81. What can I multiply 4 times to get 1? 1. What can I multiply 4 times to get 81? 3. 81 is 3 4 times. So that means the fourth root of 1 is 1. The fourth root of 81 is 3. So instead of the fourth root of 1 over 81, we can just say 1/3. Here, -4 raised to the 6th power, and then taken to the 6th root. So you're kind of canceling them out, but with a negative. So we can't just say that -4 to the 6th power to the 6th cubed to the 6th root. We can't say -4 to the 6th power to the 6th root is -4. Let's do it. -4 6 times. One, two, three, four, five, 6. Negative times a negative is a positive. Negative times a negative is a positive. Negative times a negative is a positive. So if you multiply a negative number an even amount of times, your answer will be positive. So that becomes 4,096, not -4,096. Okay. So now we have the 6th root of 4,096. If we just raised 4 to the 6th power and we got this number, probably 6, right? Or sorry, it's probably 4, right? But because it's not a negative number, it's positive 4. These two are the same, and it's odd. That number will stay the same. If it's even, like we just saw here, if it's even, if the 6 is an even, it will become positive, or it will be the absolute value of that number. You can distribute the radical. N of AB can become N of A times N of B. N of A over B can become N of A over N of B. You can take this out and work it after you solve the radical. All right, so for the square root of 50, we're just going to take the factors of 50. Factors of 50 might be 2 and 25. What are the factors of 2? There aren't any. What are the factors of 25? 5 and 5. So 50 becomes 2 times 5 times 5. Square root of 50 is the square root of 2 times 5 times 5. We can't make any of those numbers smaller. This is an understood 2, right? Square root. So we're looking for 2 numbers below the radical. We have two 5s. That's it. If we have 2, that means we can take them out. So the square root of 50 can become 5 square root of 2. Let's check. Square root of 50. Square root of 2 times 5 times 5. And 5 square root of 2. I'll give you the same number in your test. That's how you know you are correct. All right, B, the cubed root of 54. Because this was the square root, we're looking for pairs. Because this is a cubed root, because of the 3 right here, we're looking for groups of 3 of the same number. 54. The factor. 54 is 9 and 6. 9 is 3 and 3. 6 is 3 and 2. So the cube root of 54 becomes the cube root of 3 times 3 times 3 times 2. Cube root of 54 is the same as the cube root of 3 times 3 times 3 times 2. We're looking for groups of 3 because that's a 3. We can pull that out. So that will also equal those become that because we pulled it out past this 3. Cube root of 2. Cube root of negative 24x to the 5th. I want to pull out the negative just because I can. Because we're going to pull something out. So I'm going to start with the negative. So I'm going to change it to negative cube root 24 x to the 5th. Factor 24. 24 can become 6 and 4. 6 can become 3 and 2. 4 can become 2 and 2. And then x to the 5th becomes 5x. 1, 2, 3, 4, 5. So negative cube root 24x to the 5th is the same as negative cube root 3 times 2 times 2 times 2 times 2 times x, x, x. Since this is a 3, I'm looking for groups of 3. Groups of 3. Groups of 3. Everything else will stay under there. So that becomes negative the 3 stays and 2 x's stay, so I can call them x squared. The 2 came out. The 2 comes out and 1 x comes out. So I have negative 2x cubed root of 3x squared. That is your final answer. Negative 2x cubed root 3x squared. All right. Example D. Example D was the 4th root, we call this the 4th root, except for number 4. The 4th root of 81 x to the 6th over 256. I'm going to distribute the radical. So that becomes the 4th root of 81 x to the 6th over the fourth root of 256. Now I just want to do them one at a time, so it's difficult. A1, x to the 6th. I know x to the 6th will just be 6 x's, right? 1, 2, 3, 4, 5, 6. But 81 will become 9 and 9. 9 will become 3 and 3. So we're multiplying all this together. 3 times 3 times 3 times 3 times all of the x. And remember this from the whole over 4 through. So we're looking for groups of 4. 4, 3, 4 x's. Fourth root of 81 becomes, that 3 comes out. 3, those 4 x's come out. That's what we have on the top. Instead of the fourth root of 81 x to the 6th, we have 3x, the fourth root of x squared. On the bottom, 256. You can do it however you want. Let's do it really slowly. 128 and 2, 64 and 2, 8 and 8. Those just keep coming down. All right, so 256 is changed to 1, 2, 3, 4, 5, 6, 7, 8 twos. And remember, we're doing the fourth root, 256. Fourth becomes the fourth root of all of this. We're looking for groups of 4. We have 2 groups of 4, so we can pull a 2 out, and we'll pull another 2 out. We'll just multiply them together. Fourth root of 256 becomes 2 times 2. 1, 4. It works. So your final answer will be 3 x fourth root of x squared over . Now you're combining like radicals. The key word is like. So if they are not alike, you cannot combine them. So we want to make them alike. If they're alike, they have the same index or root. That's this number right here, with the 3 or the invisible 2. And the same radicand, the number under it, the 5 and the 20. So these are not the same radicand. They are the same index. Here the index is 2. Here the index is 3. So they both Both examples have the same index, so that's good. You couldn't combine them if they did not. The same radicands. So you have different radicands. Are 20 and 5. Here's your radicands are 8x, negative x, and 64x to the 4th. So those are very different. You want to find a way to give them the same radical. Negative 4 square root of 20 plus square root of 5. Just like we did before, 20 can be 5 and 4, 4 can be 2 and 2. So negative 4 square root of 20 can also be called negative 4 square root of 5 times 2 times 2. You can pull out the 2 because there's a 2 here. Right? We can pull out the 2 because there are 2 2's. Negative 4 times 2. And then we're going to bring that plus 5 down, right? In all of these, there was a plus square root of 5. Negative 4 times 2 is negative 8. Negative 8 plus 1, right? Because they have the same radicand. So now we're just adding the number in front of it. A negative 8 and a plus 1 is a negative 7. Negative 7 square root of 5 is your answer for A. B, 8x. Let's just take them one at a time. Here, we'll start B now. B is factored. There are 3 2's. 3 times 2. All the buttons are there. That was our first number. 2 different numbers. Just clear. Plus 5. Negative. You take anything out. You can take out the negative sign because it looks like it would be helpful if these matched, right? If the radicands match, we'll take the negative out. Now we have plus negative 5 equals x. Plus a negative, you can also just say the minus. So now we have 3 times 2 is 6, right? 6 x minus 5 equals x. What was our last one? Our last one was 64. Oh, sorry. 64 x to the 4. 64. 8 and 8. Okay. 4 and 2. 4 and 2. 2 and 2. 2. And we had 4x. Versus 3. Not a 64, huh? 3, so we're looking for groups of 3. 3 2, 3 2, 3x. So we can take that out. Plus, this is the plus up here. That 2 comes out, another 2 comes out, and an x comes out. There's an x under here. Oh, good, we have the same radical. So now 2 times 2 is 4. Six minus 5, don't combine it with the positive 4x because I have an x. So the only like terms are 6 minus 5. 6 minus 5 becomes 1, right? You didn't need the 1. You could just write the plus 4. So you could say 1 cubed root x plus 4x cubed root x, or cubed root x plus 4x cubed root x. That's your final answer. Either of those is your final answer. Okay. Rationalizing the denominator means making this a whole number, taking away the radical. To take away a radical 3, we multiply, right? This is the 2, 2 3s underneath the radical would help us take the 3 out of the radical. So let's multiply by square root of 3 on the bottom. Anything we do to the bottom, we have to do to the top. So that becomes 2 square root of 3 over square root of 3 times 3, which is square root of 9, which is 6. Here, we do not need to multiply both sides by 5 square root 2. You can just multiply it by square root 2. That becomes 3 square root of 2 over 5 square root of 2 times 2. Since there's 2 of them, we cancel out 5 times 2, 10. Answer. All right. Fractional exponents. You can do this in your calculator. What was it? 9 1/2. If you get a whole number, perfect, you're done. If not, you might need to work it by hand. All right, so the numerator of the fraction will go right here. The denominator of the fraction will go right here. So 9 power of 1/2 becomes this. The denominator goes here. The numerator goes here. And 9 goes here. 9 to the first power is 9. That's an understood 2, so we don't need to write it. Square root of 9. Also 3. Oops, sorry. 3. So you can write it like that, you can write it like that. It's the same problem. Very important that you have the parentheses. -8, the 1/3. That means the 3 goes here now instead of the 1 still goes here, and the negative 8. Okay. That becomes, again, you can put either of these into your calculator. It should give you -2. Because -2 times -2 times -2 is -8. 3 times -2, sorry, -2 3 times, right? We'll give you -8. So we got this is 3. This is -2. 12 to the 1/2. Our screen B becomes 12. Where is 2? 3 times 2. What can I take out? I can take out the 2 2's. Square root of 12 is the square root of 3 times 2 times 2, which is 2. That is the end. As far as you can do it. Letter E. Before to 1/3. $54 becomes 9 and 6. 9 becomes 3 and 3. 6 becomes 2 and 2. The root of 54 can also be the root of 3. Oops. 3 times 2. Just make sure. 3 times 3 times 3. 54. Whew. All right. So, because that's 3, you can take out the 3 3. So, the cube root of 54 becomes 3 cube root of 2. E is 9 3/2. So you can either do 9 to the 3rd power now and then square root it, or you could take the 3 and pull the 3 out. Do you know the square root of 9? Square root of 9 is 3. Three times 3, or sorry, 3 to the 3rd power is 27. You can do it the other way too if you want. Square root of 9 to the 3rd power, 9 to the 3rd power is 729. And you square root 729 is 27. So either way. Letter F. -27. 4/3. The 3 goes here. The -27. 4 goes there. so on your calculator, can you cube root of negative 27 is negative 3. So you can take the 4 out. Raise it to the 4. Negative 3 to the 4th is negative 81. Or you could take negative 27. Oops. To the 4th. Put that all. Two, 3, 6. 5. You can put the negative. Yeah. Two 5 times is 36. Two to the negative 3 is the same as 1 over 2 to the 3rd, right? And 2 to the 3rd. One more. 8. Hmm. 12 over 8. Oh, let's produce 12 over 8. 12 and 8. We can divide both of those numbers by 4, right? 3/2 instead of 6. 12 8. So that will become the 2 goes here, the 3 goes, the 2 here, the 3 here, the 16. So we know that the square root of 16 is 4, right? 4 to the 3rd is 64. We just did. All right, 3 more. We're going to rewrite this. We're going to distribute this to this x and this y. We're going to combine the x's and the y's and make it as simple as we can. So y 1/2. I'm just going to put now I'm going to distribute it. So separate the x and separate the y. X is 1/3. Y is a negative 3 times -3. And 2/3. -3 times 2/3. Alright, -3 times 2/3 is -2. -3 times 2/3. Now we have x times y to the 1/2 times x to the 2/3 times y to the -2. Now we need to combine. This is a 1, right? And x, 1x, 2/3, and x to the 2/3 power. We need to combine a y to the 1/2 and a y to the -2. So let's add those fractions. X, 1 and 2/3. I want to put them so they have the same denominator. 3/3 is 1, right? And then we're going to add 2/3. And then you multiply, you just add the fractions together. I changed the 1 to a 3/3 because 3 divided by 3 is 1, but now it's easier to add those fractions because they have the same denominator. Times y, 1/2 plus -2, but we want to turn it into halves. So it would be a -4/2. Right? -2, but I want to change it into halves because it's -4/2. So when I combine these, +3 plus 2/3 is 5/3. 1/2, we're just going to say -4/2 is -3/2. So now we have x to the 5/3 times y to the -3/2. So we have simplified this to this, but we can't have negative exponents. It says only positive exponents. This one's negative. We want to make it positive and move it to the bottom of the fraction. So right now you could say all of this is over 1, right? If you wanted to make it into a fraction, you can make anything into a fraction by just putting it over 1. 5 is the same as 5/1, right? So now I need this to be a positive exponent, so I'm going to move it down here with the 1. X, 5/3 over y, 3/2. Now positive because I moved it down the denominator. All right, next one. Three, x 1/2, -2. I can take that even further. You say 3, -2. So now I'm just distributing it 1 step further. 3 to the -2, x to the 1/2, the y, 3/2. Let's combine these. -1/2 times -2 is -1. We're multiplying it because it's outside. Just like here, multiplied -3 times 2/3, we got -2. 1/2 times -2, -1. Here we have 3 halves times -2, we get -3. -2, x -1 over y -3. Now, that's quick, but some of them are negative. All of them are negative. So let's switch them, right? Let's move them. Here, this was negative, so we moved the y down. I see the 3 is negative, so I'm going to move the 3 down. Now I have x -1, 3 +2 because I moved it down, y -3. The y is negative, the x is negative, everything's negative. So you can move the y up first or the x down first. If you move the x down, you have to leave a 1 up there. You just have 1 over x, 3 squared, y to the -3. Now we move the y up. So now you don't need the 1 anymore. Y to the 3rd over 3 squared x, right? And 3 squared x is the same as 9. Y to the 3rd over 9. All right, I think we're on our last problem. Eight to the 1/3 x squared to 1/3 y to 1/2 to 1/3 over x to 1/2 to 1/3 y to 1/3. Fighting 2 times 1/3 is 2/3. Over 1/2 times 1/3 is 1/6. Fighting 1/2 times 1/3, 1/6. So because we have one inside and one outside the parentheses, you're raising the exponent to another exponent, so you're multiplying them. So I'm going to rewrite it. 8 to 1/3 times x. X is now to 2/3 times y to 1. Sorry. Y is 16 over x to the 1/6. The y is 50. Now we have some x's on the top and x's on the bottom, x's in the numerator and x's in the denominator. So you can subtract these fractions. All right, subtract the exponents, just like if it was a to the 5th over a to the 3rd. That can be a5 minus 3. This can be a squared, and you're done. A squared on the top. So a5 over a3 becomes a squared. This is harder because it's a fraction, but we can do it, okay? 8 to 1/3 stays. 8 to 1/3 x, we have a 2/3 minus a 1/6. X 2/3 minus 1/6. Y, we have a 1/6 minus 1/3. right? So 2/3 and 1/6, we need a common denominator. 3 and 6. If I multiply this by 2, the common denominator will be 6, right? So it's x 4, 6 minus 1, 6. Same here. If I multiply the top and the bottom by 2, I'll get a common denominator of 6. Y 1, 6 minus 2, 8 stays 1/3. So 8 to 1/3 x 4, 6 minus 1, 6 is 3, 6. Y 1, 6 minus 2, 6 is negative 1, 6. Right? How can I simplify 3 divided by 6? You divide them both by 3, you get 1/2, right? 8 to the 1/3, x to the 1/2, y to the negative 1, 6. One more thing to do, move the y to the bottom so that it's a positive. 8 to the 1/3, x to the 1/2, over y to the 1/6. And you're done. If you want to do x to the 1/3, x to the 1/3 is the cube root of 8, which is 2. So you could say 2 x to the 1/2 y to the 1/2. All right. And those are our 8 notes. Good job, guys.